So what we've done before is we used values that were on our circle, and now in example 6 and 7 we can use right triangles to help us find exact values for the composition of functions. These values, -3/4 is not on our circle. Cosine of 2/3, not on the circle. So what we're going to have to do is we're going to have to draw a triangle. You are still going to have to draw them in the correct intervals, or in the correct quadrants. So if we're talking about the arctangent, if we have a negative value, well, our arctangent is only defined in quadrant 1 and quadrant 2, and it's positive in quadrant 1, but in quadrant 1 and quadrant 4. So since we are in a negative, we can only be in quadrant 4. So we're going to draw a triangle. It looks like it should be in quadrant 4. And we're going to use our SOH CAH TOA to help us draw this triangle. So remember, the tangent of y is equal to, the tangent of a value is equal to x or y over x. So, or your opposite over your adjacent. So we're going to say this is 3, -3, and your adjacent is 4. So what we're going to do is we're going to use the Pythagorean theorem to figure out what our third side is. So Pythagorean theorem says that we're going to take 4 squared plus -3 squared and set that equal to our hypotenuse squared. So it's going to be 16 plus 9 equals h squared. And then we're going to say 25 equals h squared. H is equal to 5. Now you should know this already. This is a 3, 4, 5 Pythagorean triple. So what this triangle helps you figure out is the cosine. We want to find the cosine of this triangle. Okay, the arctangent, whatever is on the inside, this helps you draw your triangle, tells you which quadrant you need to draw it in, and then you find this actual function that is on the outside. So in this case, we're going to find the cosine of this triangle down here. So our cosine is your adjacent over your hypotenuse, or another way to say it is your x over your r, your radius. So we're going to say our adjacent side is 4, our hypotenuse is 5. And that, my friends, is how you use a composition of functions to find the cosine. So let's try B. Remember, what is on the inside? This helps us draw a triangle. And if it says the arc cosine is 2/3, so the arc cosine is only defined on quadrants 1 and 2, but we need to know where the cosine is positive. So we're going to draw a triangle in quadrant 1, so that's where cosine is positive. And cosine is, we've already talked about, the adjacent over the hypotenuse. So you have to use a lot of remembering here. So we're going to take our adjacent side, which is 2, and label our hypotenuse. So this is going to be a 2 here. Our hypotenuse is going to be 3. We need to figure out what our y value is. So we're going to say 2 squared plus y squared is equal to 3 squared. So 4 plus y squared equals 9. Subtract 4 to both sides, you get 5y is equal to a square root of 5. And since we're in the quadrant 1, that's going to be a positive radical 5. So what's on the inside helped us draw our triangle. What is on the outside? This is a function we're trying to find. So we are actually trying to find our sine of theta for this triangle. And our sine is opposite over the hypotenuse, which tells us our opposite side is radical 5 over our hypotenuse, which is 3. So don't be scared. All you have to do is draw a triangle from what's given on the inside. And remember, this has to be within your range. And then you just find the outside function of that triangle. Bada bing!